Assalamualaikum warahmatullahi wabarakatuh. Today I will present to you tsunami warning alarm. So, tsunami warning alarm. This is my name, Nura Binti Nurizan, metric number 2010912039. A brief introduction to my project. The purpose of my project is to warn the user when a tsunami is approaching. The IR sensor generates a signal if there is any anomalous sign in front of it. To notify the user, this signal is sent to the speaker. For my project, I use more model state diagram to start the logic design. Problem statement. The wave height of a tsunami that starts in the vast ocean is extremely low. Tsunami in wide ocean seas may go undiscovered as a result of this. For example, a fisherman out on the ocean may only feel a slight swell while a tsunami wave passes beneath him. Tsunami can be incredibly wide, extending more than 1,000 football fields across, even though they are not particularly tall while they are at sea. They can also travel at the speed of a jet plane in deep ocean waters. The tsunami slows in speed as it approaches the coast and shallow water, yet it grows in height. When a tsunami hits the shore, it unleashes a massive quantity of energy as well as waves that can reach heights of over 100 feet. As a result of this tsunami warning system, individuals will be notified if a tsunami is approaching and would be able to seek high ground to save their life. So for my project objective, to design a circuit that can be used to give warning when there are abnormal signs of the water. Second, to detect and locate which area that will be affected if there are any abnormal signs. So this is the flowchart to complete my project. First, find suitable title based on the theme, and then create project proposal based on the selected theme, uh, and then submit proposal. If my proposal get rejected, I start back from create project proposal based on the title, and then if my proposal got accepted, I proceed with mini project report and construct truth table, KML, and circuit. Uh, from the truth table, I construct run the circuit from the circuit, and then if my circuit can be run, I start back with construct truth table, KML, and circuit. And if my circuit can be run, I'll make a demonstration of the circuit and complete the report. System design. This is my state diagram. Uh, in normal state, there is no output and there is no wave from any direction. When the wave comes from location 1 and location 3, speaker 1 will produce sound. When the wave starts to come and there is no wave come from location 1 and location 3, it will return to normal state. When the wave comes from location 2 and location 3, speaker 2 will produce sound. When the waves stop coming from location 2 and come from location 1, speaker 1 will make sound. When the wave comes from three locations, location 1, location 2, and location 3, both speakers will produce sound and will return back to normal state when the waves stop coming from the three locations. So this is my state table. The present state, QA, QB. Input, I have three input here, location 1, location 2, and location 3. Next state, QA plus, QB plus. Output, for my project, there are two outputs, SP1, SP2. JK flip-flop, JA, KA, JB, KB. So there is my kernel map for SP1. Using KMap, I got SP1 equal to QB, SP2 equal to QA, JA equal to QB bar L1, L2, L3, or QB L1, L2, L3 bar. For KA, I got QB bar L1, L2 bar L3. For JB, QB bar L1, L3, or L1, L3. KB equal to L3 bar. So this is the circuit diagram that I construct just now. And for discussion, this is my state diagram that I draw using digital software. And from this state diagram, I can click here, create, and choose state transition table, and this table will appear. And then click create, and I use JK flip phones, and the circuit will appear here. And to simulate the circuit in normal state, 001, here we click here first, and then there, as we can see, there is no output here, and 010, still no output as it is in normal state. 011, still in normal state. 100, still in normal state. 101, speaker 1 will be activated when we input 101, and then 110, speaker 1 will deactivate and speaker 2 will be activated. And then when the last one, when we input 111, both speaker will be activated. To conclude my project, this project impact to society or industry is the tsunami alarm is important to society as it used to predict tsunamis and send warnings in advance to reduce loss of life and property damage. The 1983 Japan Sea earthquake tsunami is a treasure source of true tsunami species among recent tsunamis. Several tsunami features were observed from hills and airplanes during the 1983 disaster, and they were captured on video and in photograph. The majority of them are vividly depicted in an HK video that was edited and published, according to Japan Broadcasting Corporation Japan. Tsunami research has been growing in Japan as a result of the country's high frequency of tsunami disaster in contrast to other countries. So, overall conclusion for my project: to limit the loss of life and property due to a tsunami, multiple distributed initiatives in tsunami detection, warning, and preparedness are connected together. In the case of a tsunami, all of these disparate activities must come together in less than a day to develop an efficient, adaptable response and function as one unit. The development of effective organizational structures that enable reliable and sustainable operation is non-tsunami in non-tsunami period as well as during catastrophic disasters, especially given the limited time available to respond in a crisis, is a problem for tsunami warning and preparedness initiative. That's all from me. Thank you.